Alright, ladies and gents, we're going to talk about quadratic and cubic functions, and more specifically, their inverse. So at this point, you should be comfortable finding the inverse. But just in case you're not, we're going to do two examples of finding the inverse of a quadratic function, as you can see in this column here, and a cubic function in this column. Okay? We'll talk about domain restrictions a little bit later on, pretty much in class. Other than that, we're going to go through this process of finding the inverse. Okay? So let's do this. First, the quadratic function. This is a quadratic function because it's a power of 2. This is a cubic function because it has a power of 3. So let's go ahead and take this function and find its inverse. So if you remember, we're going to replace f of x with y, which we did in this step. Okay? And then after that, we're going to switch the x and the y. So let's write that out. So if we switch the x and the y, it looks like this. Okay? And then the next thing we're going to do is solve for y. So when we solve for y, I'll do the work here. I need to get y by itself, so I'm going to multiply both sides by 8. So let's do that. And we are left with 8x equals y squared. And then we're going to take and get rid of the power of 2. And if you remember, to get rid of power of 2, we square root. So in essence, I like to put the y's on the left. We have the square root of 8x. Okay? So now I'll actually introduce why we do a domain restriction. What this domain restriction is saying is x has to be bigger than 0. So in other words, x cannot equal negative numbers. Okay? Cannot equal negative. And the reason for that is if you look at this equation here, if x is a negative, that means we are taking the square root of a negative number. And if you remember anything about square roots, you can have a negative number inside the square root. So in order for us not to have negative numbers inside the square root, we would have to put this restriction on x. We only can plug in positive numbers for x to keep the square root inside positive. All right? So that's a slight explanation of why we have to restrict the domain. Okay, last step is we're going to replace y with f of negative 1 of x. So it simply is this. Remember, the negative 1 is letting us know that we have the inverse. Okay? All right. So what I would like you to do is just confirm, do a composition here, and then to check if these are actually inverse functions of each other. We're going to move on to the cubic. Okay? So cubic. All right. So in a cubic, it's a power of 3. There's no restrictions needed, as you will see in a little bit. All right. So first step is take f of x, turn it into y. Next step is flip x and y, or switch x and y. So we have x equal y to the third over 8. And now we're going to do the process of solving for y. So I'm going to multiply by 8, just like we did before. And then we get 8x equals y to the third. And then to get rid of a power of 3, we do what is called the root of 3. So let me just give myself a little more space. So to get rid of power 3, we are going to change the color. And we put a little 3 here to let everybody know we're doing the root of 3. Because the root of 3 cancels out powers of 3. So we can cancel this out. again, the root of 3 is slightly different than the square root that we have over here, okay? So the power of 3 and the radical 3 cancel out, and we're left with y equal to root of 3, 8x. Okay? Because it's a root of 3, we actually can plug in negative numbers in here without messing anything up. All right? We'll talk about radical 3 in a bit, but for now, just let's continue with the inverse. All right, so there's no restrictions. Again, we can plug in negative numbers. It's not going to give us any negative radicals. All right, change y into f of negative 1 of x equal to radical 3, 8 times x. Okay? Again, check if these are inverses by composing and go from there. Okay guys, so now what we're going to do is we're actually going to take this function, we're going to find his inverse, and then we're going to compare the original graph to the inverse graph. Alright, so let's first find the inverse. I just showed you the steps, so let's go ahead and do this fairly quickly. So it turns into y, x to the third minus 5. Switch the x and y. And now solve for y. So we're going to add 5. And we're going to get rid of the power of 3 by doing radical 3 to both sides. These cancel out. Y equals x plus 5, and this is radical 3, or root of 3. And then we turn y into f of negative 1 of x. Alright, so that's my inverse. Okay, so let's go ahead and graph both the original function, which we should all know how to graph, and then I'm going to graph this function. Okay. So if you remember, to graph these, we use our original point, 0, 0, 1, comma 1, negative 1, comma negative 1, because it's a cubic, power of 3. And then we do our A, B, H, and K. So I'm not going to bore you with the process. We should be fairly comfortable with it. So I'm going to go ahead and just do all the work and not waste much of the video time. All right? Okay, so if you graph properly, here's my work. A, B, H, and K are here for the original graph. Here's my 3 points. I labeled them for you. And now we're going to graph the inverse. What I mentioned before, maybe a week ago, is that inverses, if you recall, in one of our steps, all we do for this step to this step is switch the x and y. Okay? And that's huge because that's actually the definition of inverse. We're going to take the x and y. So if you look at our original points, instead of trying to do all this graph here, because these are inverses of each other, I'm going to take my original points and simply switch the x and y. And that's going to actually give me the inverse graph because that is the definition of inverse. All right? For example, my original points are here. These are my final, oh sorry, not original, but my function up here. These are its final points. So what I'm going to do for my inverse is take each one of those points and I'm going to flip-flop these. Instead of x being 0, it becomes y. Instead of y being negative 5, it becomes x. So this guy is now negative 5, 0. We do that for the next point. This is going to be negative 4, 1. And last is going to be negative 6, 1. Okay, so let's plot these points and see what happens. So negative 5, 0 is here. Negative 4, 1 is here. And negative 6, 1 is here. All right. So if you look, we have this, and in essence, what simply has happened is we've taken this graph and its inverse turns into this graph. Let me move this point real quick so it doesn't get confusing. So our graph will now look like this. So if you look at this, it's basically the cubic sideways. Okay? And this is by definition our inverse function. Okay? So anytime you want to find the inverse graph of a function, find the original function, graph it using A, B, H, and K, and to quickly find its inverse graph, you just flip-flop X and Y, and it should give you the inverse graph. All right, let's move on. Let's try another problem. Okay, so let's find the inverse of G. So quickly, let's go Y equals 12x squared to find the inverse. Flip-flop X and Y. Again, here's that flip-flop step. Okay, we're switching X and Y here, just like we switched the X and Y in the points. Now solve for Y. So I want to divide by 12. And then we want to get rid of the power of 2, which means we square root it. And then Y is going to equal the square root of X over 12. And now we have the inverse. Sorry, it should not be f of x, it's going to be g. That's the name of our function, and it's x over 12. All right, so we're going to graph 12x squared. Keep in mind, since it's a power of 2, we now have a quadratic. So that means we have different original points. So I'm going to plot down the original points, and then I'm just going to do the graph for you, and hopefully you can follow along. All right, so the original points, if you remember, for a quadratic are these. 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. So it actually has 5 original points, and we still want to do the A, B, H, and K. So the A value, if you look, is 12, B value is 1, H value is 0, and 0. So I'm going to do this math for you. You should be pretty good at doing this already, and I'll get your final points. Okay, so these are the final quadratic points. Notice the H and K are 0, so I really didn't have to do anything for H and K, so I just left it after I did the A and B. And then also notice that the points are really large, so I adjusted our graph, so it's going by tens, both for the y-axis and the x-axis. So let's go ahead and graph these. Okay, so here's my quadratics, very skinny parabola. I labeled the points. All right, now to graph my inverse, instead of trying to really graph this thing, we'll learn how to graph these things specifically later, but because it's inverse, I'm simply going to switch my x and y values. I'm going to flip-flop them. Okay, keeping in mind that my, well, we'll talk about it later. But let's just flip-flop these and see what kind of graph we get. Okay. So, if we flip-flop, 0, 0 stays the same. We get 12, comma 1. 48, comma 2. 12, comma negative 1. And 48, comma negative 2. Okay, so if I graph these things, it looks like this. 0, comma 0. Alright, and then we're going to have 12, comma 1. So let me do some little erasers here. So 12, comma 1 would be 12, comma 1 would be about right here. And then 48, comma 2. And then we're going to have this graph. Okay? Something I want you to notice is I did not graph these guys here. And this has to do with my restrictions. Remember, I cannot have negative x's. Right? So before I flip-flop these guys are negative x's. So I can't plot these because square roots can have negative x's. So it's basically we only do half of the parabola, and we do the top half like this. Okay? But just for argument's sake, if I did graph them, it looked like exactly like the parabola we have here. And I'm going to use a dotted line to represent the bottom side because it really doesn't exist. Okay. All right, that's it.